coordinador asociado del doctorado en Ciencias e Ingeniería, director de la maestría en Sistemas Ambientales y líder del grupo de investigación en contaminación atmosférica. Es miembro del Sistema Nacional de Investigadores Nivel 2 y de la Academia Mexicana de Ciencias. Asimismo, ha servido como miembro de diversos comités del ámbito académico, sector público y sector productivo en temas de energía, medio ambiente y sustentabilidad. Actualmente es miembro del Comité Técnico de la Red Temática de CONACYT, en la que estamos, Redcam, líder de la Red de Tecnologías Inteligentes para la Cadena del Valor de la Energía del Proyecto de Monterrey y representante del TEC de Monterrey ante el Global Consortium for Sustainability Outcomes y la University Climate Change Coalition. El doctor Mendoza tiene a su cargo la iniciativa TechNexus de la Escuela de Ingeniería y Ciencias del Tecnológico de Monterrey, que busca, entre otras cosas, migrar el ámbito de acción del Centro del Agua a un centro integrado de agua, energía y alimentos. Pues muchas gracias y seguro va a ser un panel muy interesante.
Muchas gracias, Maru, y muchas gracias a todos. Bienvenidos a este segundo panel. Dadas los orígenes de los panelistas que tenemos, vamos a hacer el panel en inglés. So, given that, once again, thanks everybody, and welcome to this second panel that we have titled Air Quality Networks. Are we ready for version 4.0? And the rationale behind the name that we established for the panel was that currently we hear very frequently such concepts as Industry 4.0, Manufacturing 4.0, Cities 4.0. So everything is 4.0 in terms of the deployment of these new technology solutions, IoT, Internet of Things, big data, mass sensing, so on and so forth. And these are being used frequently for many different sectors. And the question that arises is, where are we in terms of air quality and in terms of these solutions, and that they can be embedded in what we are used to see in terms of air quality networks. And there are a bunch of different, as I said, solutions that are out there, and we are still, I guess, struggling to figure out how are these going to be connected into something that makes sense for the future of the air quality networks. And the bottom line here is that I guess that one thing that some of us believe is that we need to leapfrog into the new establishment of things in terms of air quality networks. And the question that we have is, how can we use these tools of the 21st century to actually tackle a problem of the 21st century, but not leaving behind some of the paths that we have to still try to figure out. So with that, I have invited a team of four great panelists that are going to be talking to you about different aspects on this sense. And podemos ver las semblanzas, por favor. Starting, we are going to have Felipe Adrián Vázquez. Felipe Adrián is from la Universidad Autónoma de Ciudad Juárez. He is also a member of the Comité Técnico Académico de la Redcam. So there you go. Felipe Adrián terminó su licenciatura en 1982. Año que fue otorgado su título de químico por el Departamento de Química de la Universidad de Texas en El Paso. Realizó su posgrado en la misma universidad, donde obtuvo el grado de maestro en Ciencias en Química en 1985 y el grado de doctor en Filosofía también en el área de aerosoles atmosféricos por el Instituto Mexicano de Tecnología del Agua. Desde 2014, labora en el Departamento de Ingeniería Civil y Ambiental como responsable del Laboratorio de Climatología y Calidad del Aire y como coordinador del Centro de Innovación y Transferencia de Tecnología del Instituto de Ingeniería y Tecnología de la Universidad Autónoma de Ciudad Juárez. Su área de especialización en la química atmosférica y la calidad de aire urbano. Se ha desempeñado como delegado de la Comisión para Asuntos de la Frontera Norte, subprocurador federal de Ambiente, subsecretario de Gestión en la Semarnat, director ejecutivo de la Comisión de Cooperación Ambiental de América del Norte y coordinador general del Servicio Meteorológico Nacional de México. Felipe, muchas gracias. Thanks a bunch. allow me to present the rest of the panel. Michael Ogletree is the Air Quality Program Manager in the Denver Department of Public Health and Environment. He serves as subject matter expert for citywide air quality projects. He is the lead project manager for the Love My Air programs that he's going to be describing today, among other things. Sorry, todavía no. Todavía no. Me quedé a la mitad. ¿Puede regresar? So, yes, thank you, gracias. So I was talking about my Love My Air program, deploying air quality sensors at public schools, coupled with education, programming, and community engagement to limit the impacts of poor air quality on youth in Denver. He holds an undergraduate degree in natural science from Loyola Marymount University and a master's degree in environmental policy and management from the University of Denver. Thanks, Michael. Ahora sí, la siguiente, por favor. Our next speaker will be Michel Grutter. He is a professor at UNAM in the Earth Science program, undergrad program, and graduate program. He is the head of the Department in Atmospheric Observation and Instrumentation at the Center of Atmospheric Sciences and leads an active research group in the field of spectroscopy and remote sensing. He is part of the infrared working group in the network for the detection of atmospheric composition change and participates in the validation of satellite products. Currently, he is coordinating a project in Mexico to establish a university network of atmospheric observatories nationwide to foster multidisciplinary collaboration and education in the atmospheric sciences. Thanks, Michel. And finally, el último, por favor. We have Harold Rickebacker. He's manager of Clean Air Innovation at the Environmental Defense Fund. In their Plus Business program, he helps to manage and create innovative clean air projects and initiatives across the U.S. and beyond, primarily focusing on hyperlocal, mobile, and stationary monitoring approaches. Previously, Harold worked at the University of Pittsburgh as a teaching and research fellow in the Department of Civil and Environmental Engineering. Harold's PhD research focused on both indoor and ambient air pollution, working to uncover relationships between air quality and quality of life in low-income communities. He also did substantial research in the energy conservation districts through life cycle assessments, linking energy conservation to long-term trends in spatial temporal patterns of pollution across the greater Pittsburgh region. Additionally, Harold's resume includes stints with the Department of Energy on major demolition projects in Oak Ridge, Tennessee, and SPAWAR, Atlantic Naval Weapons Station in Charleston, South Carolina. He has a PhD in Civil and Environmental Engineering from the University of Pittsburgh and a BS from South Carolina State University in Civil Engineering Technology. Thanks, Harold, for being here. So the drill that we are going to follow, we are going to have 10-12 minutes presentations of each of the panelists, and then we are going to be moving to questions and answers. So first, I'd like to invite Felipe Adrián, which I have asked him to establishing a baseline on where we are in these different topics. So, thanks.
Thank you, Alberto. And this is kind of awkward for me to speak in English in this kind of conference, but I think that I'd like to share with you a little bit of the context of what we believe is the topic for this discussion. The next, please. Let's again. The question is, there was a lot of work we had to in the 20th century that we didn't do, and a lot of these tasks that we never completed are still critical, and still we're still missing those activities at this point. We never created a very strong legal platform to develop air quality programs nationwide. Until this point, we don't have a legal formal definition of airshed. So how do we establish a program that manage air quality airsheds if we don't have a definition of how to do that legally speaking? You know, we do have made many attempts to do this scientifically based on different criteria, but we do need to have this similar as we have with the watersheds, and have some sort of management system for the airsheds. We were never able to establish a financial system to pay for the air quality systems. I mean, how do we incentivize for cities to create, to invest in such an expensive thing as the air quality monitoring systems? Most of the municipalities do not have in their budget lines a topic that allow them to spend money on that topic. They have to do it without, taking resources from different areas of the ecology departments to serve this function. Statewide is similar. We recently had a meeting with New Mexico, Texas, and Chihuahua to discuss the different where we at in the discussion of common air quality checks, and it was Texas had like 1,500 people devoted to the air quality program. New Mexico had 300, and Chihuahua had a total for all topics, including wastewater. Solid waste, air quality, permitting, and everything, like 30 people. And so that's the sort of asymmetries that we'll still face in the case of the pending work from the last century. Most of the cities, the last panel had a very interesting discussion about tendencies and how we've been improving or not improving, or if we improved a lot or sufficiently. And the fact is that for most cities in Mexico, we don't have that. We don't even know where we're coming from, if we're improving or we're getting worse. And this is something that is something we didn't do. Simply, we don't have. We don't have 30 years of data that allow us to establish a tendency. We don't have a national robust platform of for modeling the climate. We don't even have a national database, a reliable database that allows us to do modeling for every major city in the country. And this is something that we don't have a national center for environmental modeling like they have in the US or like they have in Europe or in Brazil and many other places. They do have a system that allow them to have this climatic data, meteorological data in the proper formats and in a way that can be used for everyone. Next, please. La siguiente, por favor. The case of Mexico, we just go by the general criteria that every single community above 500,000 people need to have a network. We probably have operational, maybe 5 or 6 networks, the best, but we should be near 30, according to the number of people, the communities that do have more than 500, over 500,000 people. And this is something that, as I say, this is homework or work that we did not do last century. So the next question, la siguiente, por favor, is what are we going to do? In addition to that, is the same situation we have with our climatological network. We've been losing stations and losing data from climatological stations in the past 20 years, and we don't even have a good coverage for having climatological data for the whole country. La siguiente, por favor. So a lot of these. So what's happening right now? What we do is we have a lot of networks, not all working on the same platform technologically. Not everyone operated for the same purpose or with a common purpose. We have the states operating different stations and different monitoring stations for climate. Some of them have sensors or analyzer for air quality, but most of them are spread over different areas of different jurisdictions, and we don't have a single platform that unifies the data in order to be able to be shared and compare and establish tendencies and establish the actual conditions that we are in the country. Next one. Well, one of the things we're exploring, and what I'm going to try to share is a lot of discussion that we have had in many after dinner discussions, where we believe that a lot of the future is based on the universities and on the communities. We need to learn, or at least explore more aggressively, getting all the hands on board, all the people who are able to help in providing data to join in this effort. Next one, la siguiente, por favor. One of the options has been discussed is, how about low-cost analyzer, low-cost technology? We know we're not there yet for substituting the large analyzer networks, but we still have to have some data. And we might be able to create very low-cost instrumentation that allow us to at least have some data in a different way, not trying to accomplish what we did not do on the last century, but starting something new, something that allow us to at least focus on protecting the people, to allowing people to know what is the condition of the area is. Next one. One of the ideas is, why we don't have people, why cannot we have people measuring their own air quality at the level of their residential area, on their park, on the park in the residential area, or in the schools, or in different community locations, and why they don't take care of the same of this low-cost instrumentation, and we focus on processing the data. Next one. We might be able to establish systems where we can have these community analyzers, very low cost. I heard a phrase that I like very much to describe this low cost instrumentation. If we lost the instrument, we don't cry for the instrument, we cry for the loss of data. But if we put one of those 4 million pesos expensive instrumentation in there and we lost it, then we cry for the instrument. So what we have here is something that we can replace every year. We don't even have to calibrate. We just have to replace it. It's so cheap that we can actually be replacing the instruments every time that needs to be recalibrated. But at the same time, if we make this system to be part of the community and have the community talk back to the instrument with very basic data, very basic information, like how is your allergy today? How is your respiratory system working this day? Things that they can use on their phones, and we can capture and process under the big data algorithms and these new systems that allow us to handle tremendous amount of data. And we do that for many places in the city, not 4 or 5 stations per city, but maybe 50 or 60 or more. We probably can do that and take care of the maintenance, not by spending a lot of money on calibrations, for example, but just replacing instruments. Next. So the way they look is, the way we conceive this is perhaps you can have very simple instruments located in public places. We can teach people, we can teach the community, we can teach the students to fabricate, to operate, to learn how these systems work and take care of them, and start obtaining this data on a massive manner. Let's see. And perhaps work more in how to organize this as is being done on climate. On climate, we have the underground, different community-based systems that already seem to be very successful in collecting data and processing data. We can center our efforts in processing the data instead of getting tremendous amount of money and resources to operate the very large analyzer monitoring systems. I think that one thing that is very important to underline is we still have that pending work to finish. We have to have the reference stations. Without reference stations, we cannot calibrate the local stations. We do need to have those. But we need to produce data that empowers community to essentially be able to make decisions on their well-being. There are many other options that needs to be explored in order to make a system that is entirely different to the concept that we currently have of having one office per state, in offices in every major city to run the networks. We probably can solve this faster. The technology is here. All the necessary means are here, and probably with the proper way of putting everything together, we can have results very quickly.
Thanks, Felipe. Thanks a bunch. Excellent presentation. Quite interesting follow-up, and I'm going to ask Michael to follow up with his presentation. He's going to talk about a case study that they are being developed in Denver, in the city of Denver, which I believe is quite interesting. So, Michael.
Thank you. Everyone, thanks for having me. And Dr. Vázquez, that was a great presentation, and I'm happy to follow it with some of the work that we've been doing here in Denver. Great. So my name is Michael Ogletree. I'm the Air Quality Program Manager for the City of Denver. I sit in the Department of Public Health and Environment. I just want to talk to you a little bit about this program that we've run. You can go ahead and go to the next slide, please. To touch a little bit upon the previous presentation as to lack of funding, this is where we actually got the funding to do this. Similarly, in the U.S., I don't have all this extra money to spend on some of these innovative projects. So when we're kind of going after these, it's through grant applications. So we were awarded a grant from Bloomberg Philanthropies where we ran a pilot. So February through August of last year, we ran a pilot for 6 months. We had $100,000. And we were really tasked to kind of address a pressing need within our city. In our case, we looked at air quality and its impact on kids. So we went through that pilot. At the end of that pilot, we were then asked to submit an additional application where we were actually awarded $1 million to actually scale our project. So really what they were looking for were vision, impact, implementation, and transferability. So really kind of developing a program that could be a model for other cities around the country and around the world to kind of look at. Next slide, please. So here's how we framed the problem. So in Denver, families spend over $3,000 a year on asthma-related costs, which results in over $31 million spent annually. That's specifically with Denver public school kids. There's about 90,000 public school kids, and over, I believe it's like 97,000 have asthma. So really addressing that inequitable exposure to these populations and really addressing it as a way, the way we pitch it to kind of the governments is kind of, this is the economic impact of asthma. So really kind of honing in on that. There's been a lot of press, as there has been around here, around air quality and its impacts on health in the recent past year or two. So kind of really addressing that need. So the solution, so what we're doing is we're putting sensors at schools, and more importantly, working closely with those schools to find ways to reduce exposure of kids to air pollution. So really working collaboratively with the schools. You can see these are some of the sensors. Similarly to what we heard previously, these are custom built sensors, so specifically built for our use case. They use cellular connectivity for data and solar power for communication. And here you can see kind of one of the dashboards, and I'll talk a little bit more about this later, but kind of relaying that data to the schools in real time. So here's a little bit about how we kind of evolved the program. So kind of really closely engaging with the communities to figure out what they want, right? What they want to see out of the program. So these are some from the pilot phase where we kind of sat down here. We're with some parents kind of working through what does this communication dashboard look like? How do you guys want to see the data? What do you guys want to see out of the data? Here we were working with some of the nurses. What we found with some of the nurses was that air quality wasn't really seen as an asthma trigger and wasn't really captured as a health impact for these kids at these schools. So through these focus groups, we found out that there's a lot of lack of information and education around air quality and its impact to health, even for these nurses that are at these schools. Here we were at one of the carnivals at one of the schools, kind of just getting feedback from the community as to what the dashboard looks like. And here's one of the dashboards actually installed at the schools at the end of this process where they built the dashboards, actually installing it in one of the schools. So here's a little bit more of the engagement piece. So here you can see kind of later on in the process, we actually had here, these are much more recent, these pictures over here. So these are kind of, we have a person dedicated to engagement with the schools. So this is our school engagement person kind of talking to the principal and the nurses. You can see the actual sensor right here, close to the ground. This is actually a playground right here. Each individual school is different, so we're kind of looking at different types of placement for them. So we work with the schools to find out where they want them. So here it's kind of near a playground. Here it's kind of near like a pickup and drop off area. There's actually a driveway right here. You can see the parking lot. And here you can see a little bit of the dashboard. So I think this is a piece that's missing from a lot of the air quality programs that are out there. Kind of how do we relay this data to the communities? And I know there's been some pushback, at least on my project, from the federal government and even the state government as to, oh, you guys are putting this data out there in real time and giving this information to communities. You guys have to be very careful about doing that. And at least for me, I'd rather empower those communities with access to that data and kind of let the data kind of drive their decision making. So this is kind of a live dashboard. There's some links at the end of the slide, at the end of the presentation. But this is actually what they look like in the schools. And down here, it's a little bit fuzzy, but they can actually download raw data from their individual schools to be able to kind of use it within their schools for education and things like that. Really being completely transparent, and anyone can kind of access this data. So what are we doing? So as I said, like we're collecting all this information. How are we using this information? So the way it works in our public school district, all the schools are very different. We're not only working with elementary schools, but middle and high schools as well. So really providing them with this menu of options. So we heard kind of when we first began engaging with them on this project that each individual school is different and what they can and can't do is different. You know, some have HVAC systems, some don't. So just kind of the different types of access to these different types of programs isn't necessarily the same across the board. But we did kind of separate these in 3 different types of categories. So on the individual level, what can people do to reduce exposure as well as reduce pollution? Same for the school community. And then what can we as the city do? So examples of individual exposure reduction. So as a child, as you're walking through a school, they can see the dashboard and say like, okay, like I know that my personal exposure level needs to be a little bit lower so I can do something that may be less exertive outside. For the pollution reduction, something as simple as not idling. For the school community, kind of empowering them with this information, the school administration can then take steps to do things like have indoor days when pollution is extremely high. There's also some pollution reduction strategies. This one's pretty simple, but this is just a battery pack, right? So for things like carnivals, instead of just having a gas-powered generator, we can then just swap them out for batteries. And that's a simple way to kind of reduce some of those local sources of pollution. On the city and county level, this is kind of where the policy piece comes in. We actually just recently hired a air quality policy analyst within our group. They're kind of really looking at reduction strategies at the city-wide level. So things like rerouting traffic or prioritizing construction activity around schools during non-school times. Those are different types of policy things. And then kind of as we go a step further, this is one of our connected transportation signals, one of the traffic signals. So in the city of Denver, all of our light signals are connected. So we have a way of kind of influencing traffic patterns. So some of the technology, we actually have one right here. There's an air sensor that we're testing out at intersections to be able to overlay that with traffic patterns. So we also have IoT devices that can measure real-time traffic. So kind of looking at real-time traffic and its impact on air quality, we can then in the future dynamically influence traffic patterns through the transportation network. So just kind of looking more forward as to how we can use this information to kind of inform drive policy as well as reduce air pollution. So this is about the menu of options. So kind of really figuring out what the schools can do. We have different types of curriculum that we've developed with some of the nurses and teachers, different types of behavior change programs, asthma reduction, STEM education. So a lot of these we're kind of really working, since we're piloting a lot of this, we're taking a lot of off-the-shelf stuff, but then really also working with the schools to kind of figure out what the best use of these are and which programs really have the most impact, not only on air pollution, but also at health. So we have a data sharing agreement with our school district to be able to collect more granular health data. So then we can look at not only the air quality impacts, but also the health impacts of these different programs to see which are most effective. Some of the community engagement. So a big piece of this is how do we get people to care about air quality, right? How do we get the schools engaged, the parents engaged? Because really kind of a lot of these changes, while they might start small, if we can get people really engaged about what's going on, it'll really help kind of drive these larger scale changes. So here's some pictures of some of the stuff we've been doing. So we hired a local artist to actually paint our sensors. So they'll go out to the schools and kind of get ideas and then paint them. Some of the higher level schools will actually just have an art contest and paint their own sensors. So not only is it an engagement tool, but also when you're kind of putting these at low levels, kind of it also helps have a little bit of ownership from the school. So it hopefully reduces vandalism. We just went through a rebranding before it had a terrible name. So we actually worked with a branding agency to create this name, kind of Love My Air is kind of what we came up with. Really kind of having an ownership and feeling and really kind of eliciting an emotional response to the program instead of before it was like the Air Quality Community Action Network. It was a terrible name. Here's a cool one. So instead of just having so we're doing like innovative stuff with all of our programs as an engagement tool. So instead of having just an anti-idling sign, we're actually having an art contest where the kids would actually design the signs, and then we take those back to our public works department and then print them out. Oh, sorry. So kind of as a way of engaging, right? Storytelling, obviously I take lots of pictures because it really helps tell the story. We're also doing videos to kind of get the word out, put them on social media. And then we have these newsletters. And I think the newsletters will be very impactful, where we're actually, all the schools in our program will highlight the individual schools and the programs that they're running and the successes that they've had to kind of keep the ball rolling and keeping people engaged. Because I feel like it's gonna be a really huge part of a lot of this. This is kind of a cool one where we painted a baleta cart and then we kind of took it out and then put an air sensor on there so you can kind of walk around with it. Mm-hmm. Kids come over and it's like, oh, air quality. But it's a cool way to kind of engage with community members. Cool, so future expansions, what's kind of the next stage? So this is actually the city and county of Denver. It's about 160 square kilometers. But this is kind of like the greater Denver area. In Denver, and this is actually the non-attainment area for ozone. we were recently bumped up to serious non-attainment. So really kind of working with other municipalities to scale this and share that data across those boundaries. Because as everyone knows, I mean, air is cross boundaries, so you can't just really stop at your limits. So kind of working with other municipalities to kind of share the work that we've been doing so they can replicate a lot of that. And some of the other agencies have already expressed interest, and some of them have actually secured funding to be able to do a lot of the same work using the same technology as well as the same data platform, which is huge for us, and really sharing those across those different boundary lines. I think I might have one more. This is just kind of other interested agencies who are interested in participating in it. But just I want to really quickly talk about the limitations. So a lot of entities don't have this in-house expertise to be able to actually run or develop these types of networks. So kind of really building in the data platform, all of the correction algorithms and methodologies that we're using. So, so you don't have to have that internal expertise to actually manage this network and make sense of that data. Some of the procurement procedures are cumbersome. They're difficult. So, you know, like when we went to do it, we had to go to, you know, an RFP process for 4 different vendors. But in the US, at least, we're allowed to leverage other cities' RFP processes so they can copy a lot of what we're doing and not have to go through those same procedures. And then the funding piece is always difficult. So we're actively looking to gain additional funding. But really, if we can provide a good return on investment, if we can actually change asthma rates at these schools, like I said, there's $31 million, and we have a small population. The city and county of Denver is only 750,000. So if we can see a savings of $31 million, if we could reduce that even by a little bit, it could support the program for an ongoing time. I think that's my last one. Yeah. So just contact info. If you want to know more about the program, either lovemydenver.com or denvergov.org/air quality. And then if you guys want to look at the dashboards, like I said, anyone can see these. So if you just go to denveraq.com, you can pick a school and kind of just look at that data. Thank you.
Thanks, Michael. Excellent presentation. And now we're going to shift gears a little bit, and I'm going to ask Michel Grutter to talk about other types of solutions that of course, are out there and can be, of course, complementary to all of this.
Thank you, Arturo. Let's see if we can get my presentation going. Well, in this short presentation, I want to talk to you about remote sensing for air quality. Technology is growing very, very fast, in terms of remote sensing. The amount of air quality data products available from satellites is increasing extremely fast, And the question is, are we ready? The community, the scientific community is ready to digest all this information. And how can we better make use of this information? And what are the limitations? And this is the kind of things that we want to explore in this short time. So I want to first just give you some characteristics. What are we talking about when we talk about remote sensing? So these are techniques based on the analysis of the interactions between electromagnetic radiation with matter. And from there, we can deduce some atmospheric parameters, by doing some analysis of the spectral radiometric information that these instruments are measuring. So one of the benefits of doing this kind of measurements is that we can infer the variability of the atmospheric composition in a continuous and semi-automatic manner. That is to say, once we have an instrument in orbit, it is low maintenance, unless we want to send an astronaut there and make some maintenance, but this is usually not the case. The missions have their lifetime, they are supposed to work for so and so many years, and they should work continuously under those conditions. There's no need to take samples, take it to the lab for analysis, and the amount of errors by humans is being reduced. There are other types of errors, but the ones produced by humans are reducing this kind of measurements. We get information in higher altitudes. I mean, it's important for air quality to know how much we are exposed to at the surface, but it's also important in order to understand the effect of, for example, radiative transfer, to know all the amount of pollutants there is in the entire vertical column of the atmosphere. No? I will talk very briefly about ground-based stations, no? Because they measure equivalent things to what the satellite measured. And one of the benefits of having using satellites is that they provide global coverage. You know? And they provide variability of these parameters, and we can look at their trends. And air quality studies can be done where no ground measurements are available. And this is a very important point. No? And this is also a point in which we need to be also concerned, because I have talked to some people who said, okay, we will have a lot of information in places where we don't measure, so we don't need to measure anymore. Is this correct? I don't think so, no? I mean, it is very improbable that in the future we can declare a contingency plan just from a satellite measurement. A satellite measurement can tell us where to measure, where is important to measure, but in no way, because of all the other challenges in this determination, we need to still reinforce ground-based measurements. And this is one of the key points of this small presentation. Yes, limitations of this type of measurements is that they need a high sophistication. Instrumentally and analytically, they are costly. They have limited spatial coverage in the case of ground-based measurements. No? Large uncertainties. Like I said, these are not things that are measured in situ. These are things that are inferred from indirect measurements. No? You measure spectroscopically the radiation, and you can analyze that information and try to do some assumptions in order to get the parameter that you want. And this produces large uncertainties. And you have limited information by both ground and space observations in terms of vertical resolution. I mean, it's not the same that putting a sensor in an airplane and measuring a profile. Than with remote sensing, you don't get that kind of vertical resolution that you would want. And sensitivity is also limited, and accuracy. I will give you just very short examples of these kind of things. The next, please. If you can just click on the next.
La siguiente.
Yes, the next. In the next. Every satellite mission is very strongly linked to a strong validation strategy. That is to say, the measurements need to be validated with ground measurements in order to know whether the map that you're producing can be believed or what the kind of uncertainties they have. And for that, it is important that the countries, and especially where these data products are used, that there is a strong network of measurements measuring from the ground and comparing the data from space. No? The next. One before. For that, we have to understand that these measurements are really not measuring the same thing as a ground-based measurement. They're measuring completely different things. A satellite is measuring what we call the total column, that is the integrated concentration along the optical path of the measurement. Whereas surface concentration measured by a in situ instrument located by like a monitoring station measures the concentration. And there are problem. A very conceptual problem exists, no? That nowadays, much of the satellite data are being used without really knowing the uncertainties when converting one to the other. And this is very important. This is why the satellite measurement needs to be considered as a complementary measurement and not take it as the truth as it would be by the measurement done from the ground. And this is important to say because most of the global studies for estimating mortality from particles and things like that are taking information from satellites without really acknowledging this important difference, you know, and that there are large uncertainties when converting exposure or ground concentrations from satellite products. The next. For that, you need to build this kind of networks. We are trying to do that here in the center of Mexico. You see the region around Mexico City with a map reconstructed from satellite products to determine the total column of NO2. This is a byproduct of burning fossil fuels. And you see the distribution of the pollution. Unfortunately, we don't have maps like this every day, but we reconstruct this by averaging lots of days, like months of data, in order to produce this kind of data. But then we have to decide where we want to determine whether this information is confiable. We can trust or not. So this is the strategy that every location needs to consider when using satellite data, in my opinion. The next. So you have instrumentation like that put in the ground, but which measures similar things as the satellite, and then we can determine how these measurements compare to the ground observations. You know? And then you see important differences. You can reconstruct the evolution. For example, in this is the hour of the day. In red is what measures in the ground, normal monitoring station. In green is what we measure, just taking into consideration the lower layers of the remote sensing instrument. And they follow quite good the evolution, but there's an important bias. And this has to do with the sensibility of the remote sensing instrument, which is not ideal in most of the cases. But then you have to apply corrections, no? And you can do the same type of analysis from monthly averages. The next. Yes, another example is how CO can be also measured from the satellite missions, and how then the distribution of carbon monoxide, which is also emitted from the combustion of fossil fuels and biomass burning and so on, and then compared to the ground measurements, then you begin to have more confidence in the data, and then you can do other type of studies like trying to estimate using inverse modeling the emission strength of the important sources which are being observed from the space. The next. Also, how more instruments can be done, can be used and developed in order to observe emissions from specific point sources. No, can be volcanoes, can be industry, or what else, through cameras which have different interference filters. Then analysis can be done, and you can measure the flux of different species going out of this. This is a very promising area of research, and it can be very useful, especially in places where you don't want to get close to and risk your life. No? The next. Yes, this is another example of important data products which can be used, like ammonia emissions in the city of Mexico, very emissions which are happening in areas with waste, water treatment, and so on. And from the satellite, we can determine where more or less the hotspots are. The next. And then we can compare that with measurements done from the ground in order to gain more confidence in this. The next. These are only examples. And what is the future is that these kind of measurements done in polar orbits are now being planned to be performed. Like I told you, many things have been learned in terms of instrument development. Missions like Tempo will be measuring from a geostationary orbit, and we will have information now not once every day, like passing through our area of interest, but we will have data every hour or even more frequently. And this will improve a lot of what we can understand of these emission sources. Next. Next. So, are we ready? The answer is yes. Well, we've been waiting for this, no? to get all this rich data and to be able to interpret that data. I don't know if all this huge amount of data is growing or the capacity to store all this data is growing as fast as the amount of data that will be produced. But as long as the processing is concerned, not. I mean, we have to implement all the algorithms to analyze all this data. You have to understand that this is not only imagery, like taking photos, but you are collecting data which then has to be analyzed with many algorithms, which need to follow some approximations in order to get the data, the product that you want. No? And there's not enough capacity in many of these processes to analyze so large amounts of data. And for that, they need to apply one of these things that Alberto was talking about, machine learning, big data, and things like that. So another point to take home is that these type of measurements are complementary information. The next. Validation activities are and will be crucial when using this type of information. The next. Mexico needs to build solid ground-based networks with sufficient funding and people through institutional collaborations. Next. And create open data repositories for an easy access of the information, because as we know, many people working in different areas will be using this data, and there needs to be easy access to all this information. The next. GIS multi-layer data is being required. Next. For this type of studies. So this is where we want to go, and this is how I think we should approach. Thank you very much.
Thanks, Michel. And finally, to wrap up this third round of presentation, I will ask Harold to bring once again the flavor of the different solutions that are out there and try to make sense of where we're moving at. So, Harold.
All right, good afternoon, everyone. I'm wake you guys up. I'm standing between you and lunch, right? But again, my name is Harold Rickebacker. I reside in Washington, D.C., and today I'll be presenting a little bit about our work at the Environmental Defense Fund. As he alluded to, there's a lot of challenges as it relates to air pollution, but how do we turn those challenges into opportunities? With that being said, I'll talk a little bit more specific about case studies that we've done in Houston, Texas, in London, and in West Oakland, California. And then I'll kind of wrap up talking a little more about our objectives for clear data to action pathways and ways that we can change that data to policy implications at the city and local level. All right, first, just to start off briefly, we know a lot, and as folks have alluded to prior to this presentation, regulatory monitoring networks are sparse, right? And they do not accurately depict data at what we're calling the hyperlocal or granular scale. In the US, for the 60% of citizens that live in urban air pollution sheds, have about 2 to 5 monitors per million people. All right, now we're talking about health impact assessment, exposure models. How is this really representative of inhalation dose and health impacts at a local or neighborhood or census tract scale. Next. So the path forward, we see this recent proliferation of low-cost monitoring networks throughout the US, internationally, and the market has really driven for pollution and case studies and pilots, right? With that being said, how do we use this data? We know that children, to the point of schools, low-income communities, environmental justice communities, and often communities of color see the pollution burden at a higher concentration. So how do we pinpoint our monitoring in these locations, if it's on mobile monitoring, on vehicles, municipal fleet, or if it's stationary monitors to supplement the testing that are already there from some of our reference grade monitors. Next. So what are some of the potentials of hyperlocal insights? As I mentioned, identifying and understanding air pollution as the problem. In a lot of cities, outside of our academic silos and the communities that we're in, we know air pollution is bad. But is there awareness, a rebel rousing campaign amongst grassroots constituents where they can begin to have this conversation as well? I love seeing the dashboards in the academic building here, giving us the air pollution data in real time. You know, I think that's important in different settings. Maybe this is in a hospital, maybe this is at a grocery store. How do we begin to have that conversation? So the creating awareness piece. Gaining political backing. I think this one is really unique because generally what you see is politicians are strong on issues that they understand, right? And air pollution is sometimes really complex. We're talking about precursors, secondary pollutants, and the like. It can sometimes be intimidating for folks outside of our technical background. So how do we begin to have that conversation? How do we get in front of key audiences to begin to talk about air pollution outside of, again, more the technical community? Investigation and enforcement. How can we do this hotspot testing and significance map to really target polluters? What does compliance look like? A lot of industry, they pollute, they have the dispersion models, they have these predictions, but what is the real emission scenarios at this hyperlocal neighborhood scale? And how can we target using mobile and stationary monitors to investigate the pollutants? I won't read through them all here, but points 4 and 5, I'll talk through in the next 3 or 4 slides. Next. So again, I'll talk briefly about 3 of our case studies. I won't dive into the London case study too much, but just to briefly touch on it, we worked with what was called the Breathe London Network to install close to 100 state-of-the-art monitoring stations on lampposts and buildings and throughout London. Also collaborated with Google in their streetcars, as you know, uses for Google Earth and Google Maps, but installed air pollution monitors on the vehicles as well. Also work closely with parents and schools to equip residents with wearable or passive badges to collect air pollution data as well. And as a result of that, one of their key initiatives right now is a push for a new or ultra low emission zone or pedestrian zones where you can't idle or you can't have cars at all. And they're trying to really see if they can measure or quantitatively assess some of the pre and post PM NO2 and black carbon estimates and see if it was, again, a tangible win in that respect. Next. All right, so now I'll talk briefly about a public health intervention that we implemented in the Houston area. As we all noticed, it's been a large increase in supercharged storms over the past couple of years. And as a scientist, I can account it to global warming, right? Hurricanes have the perfect relative humidity and warmth or temperature in the ocean, where again, a lot of times they gain momentum when they near Earth's surface. Hurricane Harvey actually dropped 1 trillion gallons of rain on Houston. That's equivalent to 15 days of Niagara Falls flow on the Canadian and North American landmark. So that just puts in perspective how much water it actually was. Based on that, we had a lot of odor complaints from residents post-Hurricane Harvey. We were able to coordinate with one of our partners in California and came out with these mobile monitoring units and tested in different hotspot locations throughout the Houston area, really trying to pinpoint and understand from the emitters, from our industry, where were these odors coming from? Based on that, you can click next as well. Based on that, we saw an exceedance of the Texas environmental standard for benzene, and in some instances spiked as high as 300 parts per billion. EDF coordinated closely with the EPA They weren't as fast as we would have liked in some of the conversations. Go back. But beyond that, they were really willing to work with us and a lot of the constituents on the ground to put out a public alert and press release about this issue. Next. Based on a lot of our work in Houston, I didn't talk a bit about something that we have called the One Breath Partnership, where we partner with media outlets to put this information out. Since its conception, it's been close to 5,000 interviews, televised broadcasting about air pollution specific events. Similar to when you turn on the TV and look at the weather, hey, now you're getting information and real-time data about air pollution. And based on that, we would like to say we credit a lot of that, rebel rousing and political awareness to a recent award of the mayor to dedicate $11.4 million, $11.6 million investment on clean air projects. So that's hiring new staff, targeting enforcement, purchasing more mobile monitoring equipment to target again these source and key polluters. And again, this is just one example of how hyperlocal data, stationary or mobile, can be implemented for an investment on the public health intervention. Next. Don't want to bore you with too many maps. I hope you guys can see it well in the back, but this looks specifically at how we connected it to land use zoning and permitting and building codes. This is some of our work based in the San Francisco Bay Area. Just to briefly move from left to right, it shows that there's just one stationary monitoring in this location. West Oakland is actually an environmental justice community. Suffers from low poverty, suffers from low income and the like, and has a high percentage of low income and minority or persons of color. So what we did was we connected again with Google. We rode around in this community for about a year, tested for black carbon, NO and NO2. And based on some of these maps, we were able to identify areas that were an order of magnitude higher, and in some cases 5 to 8 times higher median pollution levels than others. Wow. That kind of says a lot. If you're thinking about a regulatory monitor in one set location, how is it really reflective of what's going on for resuspension trends and pollution and inhalation events at the hyperlocal level? Now, moving beyond that, how can we have some quantitative measures of success? We were able to coordinate and connect with an insurance company, Kaiser, in this area. It collected 41,000 insurance medical records for residents in this location. Based on that data, we were able to identify that there was a 40% greater risk of heart disease, heart attack for those who live in this community. All right, this is, I think, real unique because we dove really into the parcel level and looked at the health data by homes. All right, this is not a lot of information that you can be able to kind of have this comparison if you're looking at it from just one reference monitor. So again, next, just one example of how you can look at zoning. So what did we do with that actual data? Next. We were able to identify elevated black carbon levels in this location. A separate study, we collaborated with researchers at USC Berkeley, looked at a 100 by 100 campaign where they installed low-cost black carbon sensors in 100 locations throughout this area. Based on that, we were able to highlight what we called impact zones. All right, these were zones where black carbon was elevated, but also there was what we're calling susceptible, or you can call them just vulnerable communities, right? So everything from areas that were had a high percent of children below the age of 5, daycares, schools, and from that we were able to work really closely with the city to reroute truck traffic in this area so that it is away from residential zones. All right. One thing I didn't point out: the port of Oakland is actually the 5th largest port in the U.S. And as you can imagine, it was my first time going to the site. Thousands of diesel trucks idling and passing through on a day-to-day basis. So these communities are impacted on this. They actually have a very large homeless population in this community. So now I'm trying to think about how can you look at exposure against folks who spend the majority of the time outdoors and getting this at a higher concentration. Lastly on this slide, just to show, working really close with the EJ group was important, our community-based organization. Us with the technical heavy lifting, working with political officials, we talked a little bit over dinner last night of trust in these communities. I've done a lot of work with community engagement, and trust is one that you can't quantitatively measure. Us as scientists, we want to see the numbers, but trust is really relationship building. So working with folks who serve and live in these communities to translate the data and information, these are the folks that are going to be at the public county council meetings, raising concern about the issue. So it's not the air quality experts saying air quality is bad, but it's actually your family, friend, or yourself in these meetings that really gets the attention and priority of folks in the space. All right, next. So I won't read through them all, but these are some interactive kind of data to action pathways we are hoping to obtain in the next case studies moving forward. We've spent, a lot of time and resources actually funding projects, right, and working with organizations to do the testing and monitoring. But one thing that was unique about the Houston case study is we spent a quarter of the money that we spent in London and Oakland on this project. And really what we realized was the public awareness piece, working with the media outlets, working with the politicians really drove the funding. So now how do we begin to bring the policy experts into the conversation early? We don't want to do a pilot for 5 to 10 years, collect data, and then say, hey, this is what we found. How do we begin this conversation very early and talk about clear data to action pathways and ways that you can do a pre and post intervention and hopefully see some improvement? So that's low emission zones, cycling infrastructure, pedestrian zones, clean construction initiatives. Are you using the correct scrubbers and suppressors on your equipment? Energy efficiency programs. A lot of people don't think about the upstream impacts of energy, right? You're talking about energy use in a building. Decreasing that can divert indirect impacts at a power plant, right? So how can the stationary sources be monitored or managed? Next. And then in conclusion, the next couple of slides, I just wanted to bring to you guys awareness. We'll actually be launching a how-to guide on making the invisible visible on today in Copenhagen at the C40 Summit. That talks a lot about kind of the nuts and bolts and getting started on how you can do similar monitoring. A lot of experts in the room, right? And a lot of us are doing a lot of separate projects. So we try to condense best case scenarios, case studies, and literature reviews to really dive into ways that you can do this type of monitoring on your own, but also supplement some similar projects over the long term. Next. I won't go through this, and I'll be more than happy to share the presentation if anyone needs it, but just to make the case, what were some of the conversations we had with the politicians, right? How do you make this important? All right, students, it's studies that show scored worse on tests. I feel like that's pretty straightforward, right? Stop returns were lower. This was a study done with the EPA and the New York Stock Exchange that said that 12% decrease in stop returns when air pollution was highest. Tourism industries, no one's gonna wanna come to your city if the air pollution isn't great, nor are they gonna wanna relocate with their young children and stay there long term. So how can you use this as a pitch to talk to politicians on ways to improve air quality? The global sports market makes so much money. We know endurance athletes, if it's football, if it's soccer, they're breathing at higher capacity. The PM is going deeper into their lungs because they're exerting through exercise. So how can we make that case from the health perspective from sports? Again, the financial needs in cities and really making this conversation. And it resonates a lot with some of the politicians at the high level. Then my last slide is just to pose some questions. Next. I really use this opportunity to come to Mexico City to begin some bilateral conversations and feedbacks with organizations, community-based organizations, researchers, politicians alike, because we want to do similar projects elsewhere. We want to scale and make sure that there's a great return on investments on a lot of the projects. So how far are you from doing this type of work? What type of audiences are you in front of when you're having these conversations? In just any way, I'll be here afterwards. I'll stay the remainder. But I really want to set up some calls. We're going to be doing some webinars on the how-to guide pretty soon. So really using this as a relationship opportunity to kind of branch out and network into the Mexico City area. And then the last would just be my contact information, and thanks for your time. Thanks.
Appreciate the great presentation from the panelists, and I will ask all of them to take a stand here. We have still 10 minutes to go. So I would like to just very, very quickly open the floor for questions. If you feel comfortable on doing those in Spanish or English, so go ahead and however you want. He didn't say that, but Michael is fluent in Spanish, so he understands Spanish. Harold, not that much. But okay, so we have questions out there.
Yes. To the panelists, Ogletree?
Yes.
I have a question. What were the pollutants that you were measuring in your
Yeah, so we're focusing just on PM 2.5, just because we wanted to make sure that we we simplified the pollutant of concern instead of kind of getting to more complex. Even though we're in non-attainment for ozone, it's a much more complex thing to explain to community members. So if you guys could clarify.
And yes, and one comment, we also are doing similar work in Mexico City, specifically here in the campus. We've measured also using low-cost sensors. The problem that I have, and it's just a comment, is these sensors are not the best sensors that you can think of. They are very difficult to use, really. Our experience is that they were very useful to obtain hotspots. That was very, very, very useful and very, very positive. But they are not. I don't think the measurements are really good in terms of exposure. So my concern is how we are not going to empower the communities with wrong data or data that is out of context.
Yeah, absolutely. So I didn't get into a lot of the technical piece of it, but we actually have a hybrid network. So in our same data platform, we also have a lot of reference instruments as well as these mid-tier instruments. And we developed the platform specifically for our program, which also runs the back end for the data dashboard. So we actually apply in real-time correction algorithms, multivariable corrections, using like a 30-day look back of a rolling average that's calculated nightly to apply to the next 24 hours. And then kind of also looking at more advanced complex algorithms using like a random forest model would be kind of that next step. But we're also concerned about that data quality, as is the state and the EPA. So really trying to address that in real time.
Okay, thanks. There's another question there in the back, and then one on the front here.
Thank you, amazing presentation. I have a question for all of you. So it's related to the use of other approach in order to assess the personal exposure to pollutants. For example, the use of data gathered for mobile phones, maybe with the Calidad records, and low sensors, and, for example, use of satellite data. If you have experience in the use of this approach, and, for example, other question according to the algorithms to detect, for example, modes of transport in personal exposure, if you use this approach.
Yeah, so I think we're trying to do some of that, and we are collecting, or we're developing an app right now that could be used. And if you have a native app to your phone, you have access to like GPS coordinates and things like that to be able to look at what exposure looks like, relative exposure, as to like the nearest monitor. But if you're doing stationary monitors, you really need a high density to even be able to get close to what a personal exposure would be. So I think it's a difficult thing to do, but I think the next stage of a lot of this, if we have a dense enough network, we can do a better job of trying to figure out what that personal exposure looks like.
Anyone else want to tackle that?
Yeah, I'm not sure if I heard your question in full, but around the use of mobile platforms, I can speak a little bit about work that I've done in Pittsburgh prior to starting in DC. We work really closely with community-based organizations to similarly develop an app that was called Smell Pittsburgh, right? So similar to if you were able to call in a 411 call for something that's an emergency, but not life or death. And using that data to complain about, what your smells and odors were. We work closely with universities that kind of were able to discern between, pollutants and what that smelled like. I can't speak on the specifics itself, but we're able to just overlay that with TRI data, 411 reporting, operation hours of plants and facilities, and connected that with our health department, and they were required, based on how many complaints they received, to go out and do enforcement on those exact locations. Another instance that I can use is we did similar testing with indoor air quality, right? So we know we spend 90% of our time indoors. The doors open today, so we get a little fresh air in, right? But outside of that, a lot of the exposure that we receive from VOCs, particulate matters, from cooking, grooming products, cleaning products, and the like, And we work close with the citizen science initiative, where we essentially signed out equipment, wore passive badges, got data sent to the cloud, and they kicked out reports, and were able to discern between what activities in your home influence the air pollution. I spoke a little bit about the community awareness piece, which I think is huge, and that's just one way we thought about using like a mobile platform and kind of real-time data to increase environmental consciousness in these communities.
Okay, excellent. Let's continue with, there's another question here, Patricia.
Yes, well, it's for Michael. It's thank you for your presentation. It's a very, very interesting program. Love my air from Denver, and it's a beautiful city. I have the opportunity to be in there. And in our cases here in Mexico City, we have been working with the Ministry of Environmental Ministry in order to create with Beatriz an index, a personalized index with the combination of three pollutants, in this case ozone, PM 2.5, and nitrogen dioxide. And the idea is precisely to validate the in this case, the utility for susceptibility populations as like a child with asthma. And we have been working with adults, and with third age people with COPD. And we found an interesting correlation between the number. I mean, when we have any of these three pollutants combined with the susceptibility of these populations. But in these populations, we have some people who has much more sensibility, individual sensibility. I saw your program with your dashboard in the schools. Do you have any form to inform to the people in individual sensitivity? I mean, in order to say, for this child, maybe you have much more susceptibility, and maybe to have an alert or something like that, in order to prevent exposition, because the most important is that, to prevent in this case.
Yeah, so two things. As far as the alerting goes, the back end of the data platform will allow you to set your own sensitivity alerts and receive both email as well as text message for those different things. So as a parent, you'd also want to know as well, right? So you can set alerts based on the air quality at the school. You can get alerts. The other piece, and I think it might be really cool to develop something like this, and it's something I want to go towards, is kind of like creating an app that would allow you to register an event, right? So when you go outside, you click a button, oh, air quality is impacting me. And if you get a dense enough data set, you'll be able to collect all of that information, and then the app itself, through machine learning, would be able to set your own personal threshold, and the schools as a whole can also use that as well.
Okay. Unfortunately, we are out of time. There are I saw some hands there, but all of them are going to be here for the rest of the day. So muchas gracias a todos, muchas gracias a los panelistas por sus presentaciones, y creo que nos vamos al receso, ¿verdad? Excelente.
Los invitamos todos a tomar cafecito. Vamos a un receso